Hey folks, Phil Zito here, and in this week's episode of BAMTV, we're going to do things a little different. What we're going to do is we're going to take a lesson from our BAS Protocol Bootcamp course that discusses BACnet IP, and we are going to use that for this week's BAMTV episode. So you'll get to see what is in the course, but you also get to learn at a deep level how BACnet IP works. So what we're going to go through in this episode is going to be describing what BACnet IP is, how it works. We're going to look at network traffic in Wireshark. We're going to outline some BACnet IP networks. We're going to analyze that network traffic, and we're going to go through how BBMDs work and function. So there's going to be a lot to this episode. And if you haven't already done it, encourage you to watch the previous episodes on BAMTV because that will really help this information make sense. So with that being said, let's go and dive in to the lesson on BACnet IP. Thanks a ton. I'll see you at the end of the video. Take care. BACnet IP can be a very confusing topic for a lot of folks. But when you realize that it's really nothing more than IP traffic with a couple changes that make it quote unquote BACnet style, as I like to call it. And what's going on here is that BACnet IP is an implementation of the BACnet standard, and it's using IP as the communication method. I say physical communication layer, but I don't want you to be confusing that with the OSI model of layer 1 physical communication. It's just using the IP protocol. So what this means is that BACnet networks essentially can span multiple physical and logical network segments. That means you could have a BACnet network segment that could stretch across multiple physical subnets. It could actually be across multiple IP ranges. And that's good and that's bad. And we'll talk about why that's good and why that's bad. We'll talk about some strategies around network sizing when we move into the BACnet network slide here on the slide deck. Now, I want you to realize that if this stuff doesn't make sense on the first pass, don't worry about it. It will make sense. It just may take you a couple times going through these videos very slowly. We're going to go through a lot of network captures. We're going to diagram out networks. We're going to spend a lot of time on this protocol because this is the one that most people seem to have the most trouble with. So don't worry if it feels a little foggy at first. It did for me too. And I've been doing this for a long time. And so it's okay. All right, but before we go there, I laugh because the first sentence on this slide is, "It's time to confuse you more." All right. Well, seriously though, there's no way around not confusing you with this. You see, BACnet, it's similar to ID, or similar to IDP. I was going to say IDP. It's similar to IP and UDP traffic, except for it uses NPDUs, APDUs, and the BACnet virtual link control and link layer, which, yeah, those are some confusing topics. There's no way around it. They're very confusing. But here's the thing. They're not confusing when you understand what they're used for. So NPDUs simply exist to essentially contain the source and destination of the BACnet network identifiers. Now realize that with our frames and our packets and our segments, so frames being Ethernet, packets being IP, segments being UDP, we are going to go and have network fields that define communication between the IP layer communication. However, NPDUs define the BACnet communication parameters. So we couldn't put a device ID and a BACnet address in an Ethernet frame or in an IP packet. That would be malforming the packet. Those packets would get rejected by the network. It just wouldn't work. And the same with APDUs. So just like we have HTTP, that is a layer 7 protocol, and that's where a lot of our HTML traffic is communicated for web pages. Well, the same with APDUs. APDUs communicate the application data around BACnet. And this is where all of our service functionality happens. And don't worry, we're going to, as soon as we get through these first 7 or 8 slides, we're going to spend a lot of time in Wireshark looking at messages. And now here's the kicker. This is something that, according to the BACnet wiki site, is quote unquote very complex. I actually don't find it to be very complex. And it's good. You shouldn't find it very complex either, because all it really is okay, so in the OSI model of network communication, you have data link. And that basically is the communication on the local subnet. Well, BACnet goes and has virtual link control and virtual link layers. And this is essentially the layer 2 version of BACnet communication across the BACnet network. And this defines whether the messages are broadcast, whether they're unicast, etc., because BACnet needs to know what to do with them. So really, there's only a couple things you need to know about BVLCs and BVLLs, and we just discussed them. And essentially, when you're looking at a Wireshark capture, which is really, if we're honest with one another, this is when you're actually going to care about this stuff. Because doing your day-to-day job, you don't need to know MPDUs and APDUs and BVLCs and BVLLs. It's when you're actually troubleshooting the network that this stuff matters. So when you're looking at this, you're really looking for 3 fields. You're looking for, is this a unicast? Is this a broadcast? Or is this a forwarding of a broadcast? Those are the 3 fields as I remember them. I'll take a look at the BVL documentation prior to us leaving this, because I really want to show you the wiki prior to us finishing this lesson. And we'll just confirm that those are the 3, but I'm going based off memory right there. So the good news is, although that sounds really complex, it's not. And we'll see that as we start to dive through the individual packets and messages in Wireshark. Well, as if you weren't confused enough, we're going to dive a little bit deeper. We're going to be going through some key terms. I'm not a fan of memorization. But in this case, these are just terms you have to understand. If you're on the phone with a manufacturer trying to troubleshoot BACnet communication, you need to be speaking the same language. And so nodes, physical segments, logical segments, and these are essentially a VLAN for BACnet, but they're can be stretched across multiple subnets. Segments themselves, like I said, they're comprised of both physical and logical segments, BACnet networks, BACnet addresses, BACnet ports, device IP addresses, routers, and BBMDs and BDTs. Those are all of the things that we want to focus on as we continue to move through this lesson. We really want to make sure that we get all of those definitions down. Now, in order for us to go and make sure that we really understand these key terms, we should understand what these different things actually look like. So first thing we're going to do is we're going to diagram out a BACnet IP single subnet topology. So let's pause the video and take a look at that. Okay, so as we recall, on a single subnet, single physical network, BACnet network, what we're going to have is we're going to have a router, RTR, and that's going to allow us to connect to other networks. We'll just draw that kind of little bubble there. And then we are going to have a switch. Coming off of this switch, we are going to have a BACnet device. We'll just call it BAC device. And on the other side of the switch, let's put another BAC device. Both of these devices are going to be, actually, I don't want to put that right there. Put that kind of up here in this corner. Both of those devices are going to be network 1001. And let's say that they are going to be IP address 192.168.1.0-24. So that's local 254 host subnet. So we've got that, and then our port is going to be standard BAC0 47808 UDP port. So what's going on here is that these BACnet devices, each one is going to have a device ID, which will be unique. Let's say this one is 5000. And then let's say device ID of 5001. And we'll give this IP address down here. So this is .2. And then this one's IP address is going to be .3. And what's going on here is that when these devices want to communicate, what they will do is, for example, this BACnet device, it will go and if it knows what property it wants to read, so for example, it wants to read, let's just say it wants to read object 1001, and it knows the device ID, then it's just going to send a read property. That read property is going to be a unicast according to the BVLC, and that's the BACnet virtual link. Okay, so we're doing our read property. It's MPDU, since it's on a local subnet, is going to be pretty much blanked out because it doesn't need to have any of that information. And its APDU is going to have the read property. It's going to be a confirmed acknowledge, and this BACnet device is going to return the acknowledge. Okay? And then since the MPDU will be empty, because we're not going outside of the local subnet, however, the IP and the Ethernet frames on the message will be filled out. Now, I know some of you right now are very confused. This does not make sense to you. I get that. Don't worry. The reason I'm using this exact example is because I'm going to show you this exact example in Wireshark. And when I do that, it's going to make sense. I actually was going to show you Wireshark after I did some explanation, but I think I'm going to show it to you before, based on just kind of what I'm feeling of where you're at. I'm putting myself in your shoes, remembering when I was a technician, how I felt. And we're going to dive into Wireshark right now. So I'm going to pause the video and bring that up. Alrighty, you can see I've got Wireshark up here. And you can see I've got my BACnet message right here. Okay, both devices are on the same subnet, 168.0.13, 168.0.5. Okay, we're going to start at the top. I'm going to close these things down here, and we're going to work through. And don't worry, I've grabbed a lot of these captures, courtesy of Steve Karg's website. They are not my captures. They are captures he shares on his website, and so that's where these came from. And what I'm showing you here are the Ethernet frames. Okay, so this is going to be our IP communication. This is our network communication. Frame, Ethernet, IP, UDP. Okay, so frame is the Ethernet communication. We can see that happening right here. So we see our Ethernet frame. We see our Ethernet MAC address to MAC address, destination to destination. You can see that. Okay. We can see the card going to that device. So this was the network card that started it. And this is the destination, an Allerton controller. We see the MAC addresses right here. Then we see the IP addresses. Okay. So we see that right here. And we see the source IP address, destination IP address. Then we see our UDP, and we see we're using port 47808, our BACnet port. So all of this is our basic network traffic. So these are all things IT can help you troubleshoot. If you're troubleshooting an issue, IT can help you to troubleshoot these issues right here. However, when we move into this, not so much. BACnet Virtual Link Control. We see we're using a unicast, and we're sending the NPDUs via the unicast, right? We're sending a unicast is a single directed message. I realize we haven't covered this yet. That's okay. We're using BACnet IP, and we're using a unicast message. So we know this is directed to that IP address. We open up our NPDU, and we see that we are expecting a reply. We can also see that in the confirmed response. So we are requesting a response, so we're going to get a complex acknowledge with a value, a response being sent back. We can see that we do not have anything in our destination network, destination length, or destination address. We can see that we don't have anything in our source network, source length, or source address fields right here. We can see that this is expecting a reply. It's a confirmed request protocol data unit. We know that because we know what service type. And now we can go and we can actually see the APDU. We see it's confirmed required. Okay, we see that it is a read property service. It's being sent to this device, and we are reading object 201, okay? So we are reading the property, and what property are we looking for? Object identifier, okay? So we are looking for object identifier, and we can see that all right here, and then we can see our response, okay? So I'm just going to expand the APDU here, and we can see that object identifier, property identifier, object identifier, okay? And we can see the actual object identifier property right here and the response. Now let me show you one that is just a little bit more clear. Object name request, object name response. See, it's in the format and string of the name. Object type response, device. System status operational. Vendor name Allerton. Model name LSI controller. You seeing how this kind of works? Okay, this is how you can go and read BACnet traffic, understand what is communicating, because you understand the services now. I know this course up to this point may have felt a little slow. You may have felt like, man, I'm learning services, and why am I learning all this stuff? You're learning it because now as we're starting to get into actually analyzing traffic, which, I mean, that's really why you're learning about BACnet IP, if we're honest with one another. You're not learning about it because you don't understand BACnet IP. You're learning about it so that when you're troubleshooting BACnet IP, you can make sense of this stuff. So this is how we start to be able to go through this. All right, I'm going to bring us back to the whiteboard. Actually, to the PowerPoint. So now we are going to dive through a BACnet IP multi-subnet topology on the whiteboard. Okay, once again, we can see the whiteboard here, and we are going to draw out two subnets. We're going to make this very simple. We're going to put two routers, two switches, and each switch is going to have a device. Okay? Oops. Here we go. Okay, each device is going to have an BACnet ID. And we're going to say this is 1001, this is 1002. We're going to say that this is network 1, this is network, we'll just say 200, and network 100. Device ID, device ID, and we'll say that this is IP range 192.168.1.x/24, and this is 192.168.2.x/24, and this is going to be .2, and this is going to be .3 for our IP addresses. And we're both using 47808 UDP. Okay, now we have an addition of two new things. We have a BBMD and its associated broadcast distribution table. So we're going to put those on here as well. BDT. Oh, that's terrible looking. Hold on here. Let's clear that up. Alrighty. There we go. BDT. Okay, I know my handwriting's terrible, but that's not what you're here for. You're here to actually learn how all this works. Okay, so BDT's BACnet or broadcast distribution tables, they list the IP address of the BBMD on each subnet. So let's give this BBMD an address of 4, and for simplicity's sake, let's give it an address of 4. When I'm doing .4, that's actually 192.168.2.4, since this is a /24 network. And let's just give these routers .1 and .1. And what's going to happen here when I want to do a read property, I'm actually going to have to go to the BBMD, which is going to tell me where to send my unicast message. And I'm going to put that in a NPDU. And that NPDU is going to have the network number, and it is then going to go and have the source and destination addresses, as well as the length, and that's how I'm going to send that. Once again, this is best seen by simply looking at a Wireshark traffic capture, and we'll take a look at that right now. So we can see right here that we have a whois.iam request being sent out. Okay, so this right here is being sent out, and we see that we are going and sending out our whois.iam request. So it's being sent out. You can see it being sent out twice, and then we see our response from this device and its IP address. Once we know that, then a unicast message is sent to this device requesting the read property, and a unicast is sent back. Okay? Do you see that little nuance? How we start off, we go and we find right here kind of our BBMD address. Once we have that address, then we send out our broadcast. Our broadcast then comes back with a result, So we see that, see our result, and then, or actually, here's our result right here. We see our result, and then once we have our result, we are then able to send out our request for this read property service and get our complex acknowledgement. That's how this functions in BACnet. All right, with these two demonstrations down, let's start to go through the terms. So this is going to go pretty rapid fire because these terms are fairly self-explanatory, especially after what we've seen on the whiteboard and in Wireshark. So nodes are simply a name used for BACnet devices that are attached to a network segment. What are network segments? Well, as we mentioned earlier, there's logical and physical segments, okay? So logical segments are becoming more common, but the most common is physical segments. These are, the individual local subnet or the trunk with MSTP. But as I mentioned, with IP controls becoming more popular, you're seeing logical segments where these BACnet nodes are being stretched across multiple physical networks, but they belong to the same logical subnet. And we'll cover this later in this lesson, but it's really important to keep your subnets small because your subnets being too big, you will then have large broadcast domains, which will get really chatty, especially with BACnet being a broadcast-centric protocol for its discovery services, and that will just cause all sorts of issues. Now, when it comes to BACnet networks, the BACnet network ID defines the logical BACnet network that a node belongs to. Now, when I say logical network, I say that because you can have a BACnet network that stretches across multiple subnets. So you don't have to constrain your BACnet networks to a single subnet. It's ideal to do that. That way you can segment and it makes troubleshooting easier, but you don't have to. So BACnet networks in themselves are unique IDs for the entire BACnet inner network, meaning that when all of the networks are combined on your system, each BACnet network ID must be unique. BACnet addresses, these consist of the network number and the MAC address of the device. The reason behind that is that the BACnet network number is needed in order to communicate, and the MAC address of the device is how we go about communicating to those devices. So that is how BACnet works. The BACnet port, this is a UDP port that all BACnet IP traffic is going to communicate on. This is very important. A lot of folks will run into sites that have conflicting ports. They'll have maybe one that's 47.08 and one that's 47.809. If that is done, then the BACnet traffic is going to struggle to communicate with one another. It's ideal to have the same ports for your BACnet traffic unless you're trying to isolate the BACnet traffic. All right, so BACnet broadcasts. There are three kinds of broadcasts. Now, as we recall, BACnet services are chatty by nature. They are broadcast and unicast. There are multicast, but those are not very common. So unicast is direct IP address to IP address communication. Broadcast is where you send a message out across the entire local subnet. Broadcasts cannot travel from one subnet to another. That's why we have BBMDs to route our traffic to route our broadcasts to other subnets. That way the BACnet devices can be discovered, and once they are discovered, then we're able to go and do unicast messages between the BACnet traffic. That's what we saw in our earlier Wireshark example. Now, as I mentioned, there's local broadcasts. Those are local BACnet network and subnet network communication. Then there's remote. This is where you have a BVLC that forwards a broadcast request to a remote network. And then you have global, where you go and scan the entire BACnet inner network. Now, You want to avoid global. In most cases, you want to stick with local and remote. Now, broadcasts are determined by the destination network field. So what that means is that on your destination network field, you can go and put a value on your NPDU, on your network protocol data unit. The value you put will either direct the broadcast to a specific BACnet network or will tell it to be a global broadcast. Now, BBMDs. So BBMDs are another topic that is very difficult for folks to understand, but it's because they just haven't been explained to them. I just went through how broadcasts, they can't travel between physical subnets. But with BBMDs, they can. We have these things called BDTs, which are broadcast distribution tables, and they go and store all of the remote BACnet networks IPs. Actually, they store the BBMD addresses for the remote BACnet networks, and this is how your BACnet traffic gets sent from one IP network to the next. So let's take a look at that. We've already taken a look at it a little bit, but let's take a look at it in a little bit greater detail. So the first thing we're going to go through is just BBMD tables in general, or BBMDs and their BDT tables in general. We can see right here a BVLC writing the BACnet broadcast distribution table. We can see that we are writing the entries to this table, right? We can see them right here. Now, as we continue, we can see that we have a result, and we see that the table was written, okay? There's a couple more things in here. We can see that we're reading the table, and we can see that we read the table. And I'm going to ignore the foreign device tables, and then we can see results. We can see that we have foreign device tables being read, but that's neither here nor there. We're not going to get into foreign devices because they're not as common as non-foreign devices, which is what most of you all are going to be working with already. So why do we read the BDT? Well, we read the BDT so that we know where to send our messages, because if we don't know where to send our messages, then we're going to be in a lot of trouble, because if we can't send our broadcasts, then we can't do who is and who has. If we can't do who is and who has, then we can't get our I am and I have messages, and if we don't get those, then how do we do our unicasts? Because we can't go and add those addresses to our objects, to our devices rather, which then are going to use those addresses to do their unicast messages. And now, with all of this put together, with everything you've learned in this lesson, let's take a look one more time. So we have our BACnet virtual link right here doing a result, meaning we are getting a result. So we can see we're getting a result, and we are going to go with that result, and then we're going to send our who is. Okay? Send our who is out, and that who is goes out our source to the broadcast address right there, hence the 255. It's not always 255 for our broadcast, but that's usually what your broadcast address for your local subnet will be, is 255, and usually your default gateway will be .1. That's not always the case. We see that we send this out, and now we get our who is, okay, and as we travel a little lower here, we see that we get a I am. Okay, we're seeing that we get an I am. We have who is. We have I am. and we then are able to go about doing our read property and our read property acknowledge. Okay, we see that, and we see our acknowledge. All right, folks, I hope you enjoyed this episode. Thanks so much for watching. If you got any questions, leave it in the comments below this video. So here's what you can do to kind of continue your studies. For one, you can go watch BAMTV episodes 5 and 6 if you haven't already done so. That will really help you out, as well as listen to podcast episodes 116 through 118. As far as resources go, you can go and purchase Michael Newman's BACnet book. We'll have a link to that in the description of this video. And you can also go and purchase the BACnet 135 standard. Then, a little tongue-in-cheek here, you can go and spend hundreds of hours of studying like we did when we were researching BACnet, LAN, and Modbus for our BAS Protocols course. Or you can purchase our course, which will teach you everything you need to know in about 7 hours. So depending on how important your time is to you, depending on how quickly you want to learn BAS protocols, those are the two paths you could take. Really encourage you to check out our course and to go and sign up for that if that is something that you need to learn, which pretty much most of you watching this video need to learn the BAS protocols, especially BACnet since it's so common. So once again, thanks so much for watching. Look forward to seeing you in next week's BAMTV episode. Thanks.